So the different users, the different use cases, the different types of input and output that you need, what does that translate to as far as the architecture is concerned? It translates to a very, very different data layout. When you're retrieving a small set of rows, which is essentially the row-oriented OLTP, right? All you need is infrastructure to reach to a small set of records that you really care about. And when you go to that small set of records, you want to read all the columns. And the code is basically the entire indexing that you build on top of it. So if you're very comfortable with your databases, you know things like B trees and B plus trees, inverted indexes. And those are exactly what are core to an OLTP database. How do I, from a million records, go to those 2 or 3 or 5 records that I really care about as efficiently as possible, and then I'm going to just read those records completely. This fundamental requirement essentially means that data is laid out in an OLTP database in a row-oriented fashion. One row, the records are placed together. The columns, the values in the columns based on which you want to filter, that is used as an overlay on top of your row-oriented database. So this is essentially, if you want to only look at my records, then basically there's a field user ID which is indexed based on which I can identify which users are where. And then when I go to the record, I read the entire record. So the data itself is placed nicely, right? Row by row, row by row. And there's a separate overlay that basically pointers to where you want to go. On the other hand, in an OLAP database, you need to read pretty much a huge number of columns. And you're only going to retrieve a small number of columns. So what does that mean? That you place data one column at a time, which means that I can read one column of data without touching the rest of the columns. Which essentially means that if you have a database, let's say with 100 columns, and you only wanted to touch one column, you're saving on the IO of 99 other columns. So that's like 99% savings that you're going to get out of using a column store. Because you will very rarely retrieve independent 1 or 2 records, you really don't need the large indexing structure. You can actually work with a much simpler structure, so you don't need complex B plus trees and stuff like that. And that's something that we are going to touch upon. That's something that's going to be very, very crucial in the data modeling exercise. So this is the most important concept that fundamentally differentiates data modeling in a data warehouse from data modeling in a transactional database. And don't worry if you don't get all of it right now. One thing that you need to take away from this lecture is that in an OLAP database, which is the underlying core of what a data warehouse is, the data is organized in columns. You can read one column of data, all the records for that particular column, in one shot without touching other columns. This gives you a fundamentally very, very fast way to read column specific data. You will very rarely need to read 1 or 2 records of a column, and that is why you don't need the kind of complex indexing that is there in an OLTP database where you retrieve a small number of records. And we will leverage these particular insights to figure out what's the right data model for a data warehouse which uses an OLAP database. Thank you.